Hello, and welcome to another edition of Tech for You on CCP TV, the educational channel of Community College of Philadelphia. I'm Arnold DeBlasi, Director of Academic Computing at CCP, and as always, we try to address some current aspect of technology and discuss its implications for you. In the past, we've talked about topics like web services, uses for varied software, differing types of hardware, and even some social issues as they relate to technology. Today, we want to introduce you to one of the hottest little pieces of technology, the Raspberry Pi. Now, for longtime viewers of CCP TV, please don't change the channel thinking you've tuned into an installment of our awesome series, The Chef Cooks, because this is not your grandmother's Raspberry Pi. Viewers of a certain age will remember stories about young entrepreneurs with names like Jobs and Gates writing software code in their garage and enticing people of all ages with their new gizmos and gadgets, products with names like Macintosh, DOS, Windows, and on and on. Well, it seems that over the years, a lot of our young people have lost their fascination with and interest in the programming side of computers and technology. Something seems to have changed the way kids interact with computers. Some suggestions for this change include the establishment of the so-called basic computer curriculum with lessons that are primarily focused on using productivity software such as Word, Excel, writing web pages. Perhaps the end of the dot-com boom in the 90s, where a lot of technology lost its glamour. Or even the rise of the home PC and games console, which is replacing the venerable Amiga, TRS-80, BBC Micro, and Commodore 64 machines on which people of an earlier generation honed their programming skills. So educators and industry executives alike have pondered if anything could be done to re-spark the interest and zeal of those early pioneers. As new avenues for elementary, middle, and secondary students are forged under the STEM acronym, pushing science, technology, engineering, and math subjects, and they meet up with the new Maker movement, so-called because teams of students come together in a physical space to problem solve, collaborate, with a common goal to create a physical object. Can this be one solution to the less than optimum condition we find our students in regarding these subject areas? And that brings us to today's guest. I'm pleased to have with us today Charles Herbert. Chuck is an assistant professor and currently coordinator of the computer science program here at the college. He also served as chair of the computer technologies department here at the college and has an extensive background in the computer and technology area. He has earned degrees in education and in mathematics from Villanova University, a master's in computer science from St. Joseph's University, authored several textbooks in computer science, and has worked as a software development consultant for the shipbuilding industry. He has also produced several interactive exhibits related to shipbuilding for the Franklin Institute and the Chesapeake Bay Maritime Museum. Welcome, Chuck.
Hello, Arnold. It's good to be here.
I'm glad you could be with us today. So, what exactly is this Raspberry Pi thing that everyone's talking about?
Well, this is a Raspberry Pi. This is the original Raspberry Pi that came out a few years ago. To put it simply, it's a complete computer system on one circuit board that you can use to build projects, to learn about computing. You can really do a lot of different things with it. Build cameras, burglar alarms, all kinds of things. The Raspberry Pi has a central processing unit and memory, like any computer would have, and it's got several input and output ports on it to connect different things to the computer. This one, the older Raspberry Pi, has an HDMI port for video. It has a USB port to connect any kind of a USB device, and there's only one USB port in the original Raspberry Pi, so you'd have to connect a hub if you had more than one device, such as a keyboard, a mouse, and so on. And then on the back here, these pins are general purpose I/O pins, and that's what really gives the Raspberry Pi its power different than a lot of other things, because you can attach devices to these general purpose I/O pins, a lot of different devices, and program them. You can experiment with them. This is the Raspberry Pi Model 2, which is the newest model, and these sell for about $35 from a whole bunch of different sources. The differences between the two are largely in the input and output interfaces and in the computing power. The original Raspberry Pi had 256 megabytes of random access memory and a single core processor. This has a dual core processor and a gigabyte of random access memory. It also has 4 USB ports, so you can connect multiple devices at the same time without a hub, and it has an RJ45 connector for Ethernet networking. It's got an audio input jack, and audio output as well, just like the original Raspberry Pi, and it has HDMI for video. One of the things that they both have, besides the general purpose input and output pins that I mentioned, are 2 connectors on the board to connect devices such as cameras or display screens. If you wanted to build your own little tiny device with a 3-inch LCD display screen on top of it, would plug into those pins on the board. So that's the Raspberry Pi. There are many other devices that are similar to the Raspberry Pi. This is the popular one now because of all the press, because of the fact that it's so inexpensive, and because it's put out by a nonprofit organization. This device is called an Arduino, and the Arduino is pretty much the same as the original Raspberry Pi. They have a few different versions of the Arduino. The Arduino was actually one of the original of these kind of devices. An Italian research lab developed this for people to experiment with. In the industry, in the electronics industry, these are known as project boards. They're the basis of an experimental lab to build things. If you wanted to design a camera, for example, you'd start with this and add on all the attachments, do the programming, and so on. And the big thing about the Raspberry Pi and the Arduino and others, there's one called Hummingbird that's become popular. There's another one called Banana Pi that competes with the Raspberry Pi. And by the way, Raspberry Pi is Pi from the Greek letter of the alphabet having to do with mathematics. So the Raspberry Pi is the popular one right now, but there's more than just the Raspberry Pi.
So it sounds really robust now, especially with version 2 and the fact that they have much more memory and additional I/O ports and that kind of thing. So what kind of things are people doing with these systems in terms of home projects that I might be able to do outside of, let's say, the school children building things? What kind of things might I do with it at home?
You can do a lot of different things with these devices. One thing that's popular today is to build your own cameras. What we have here is a lens from a camera. It's the same lens that's used in most cell phones. It's the lens that's used by Samsung, it's used by Apple, and it's a fixed focus lens, which means it doesn't zoom in and out and so on. This one is a 5 megapixel camera. You can buy these for about $20 a piece. And they actually plug into the Raspberry Pi board. In addition to the regular camera, you can also get infrared cameras. You can see this one has a black board in the background. Other than that, it's the same camera. The sensor in this camera picks up infrared light. So for example, night vision photography. You can build burglar alarms. You can take pictures of animals. They have several units with cases very similar to this one that are weatherproof and battery powered with a solar recharger that they use in Antarctica to keep track of the penguin colonies during the winter. They mount them on different posts around the colonies, and the pictures are beamed back to the station in Britain that keeps track of all this stuff.
So for example, in my backyard, if I am close to wildlife and I wanted to take some images as things are moving in and out, I could have this type of a setup and place it in a remote location, perhaps up in a tree or somewhere, and be able, with a sensor and a camera, to be able to view what's going on in the back.
That's right. It's small enough so that you can put it almost anywhere as long as the animals aren't going to disturb it. You can mount it on a post, you can put it on your house. Here's a lens that would be used for something like that that's a little bit better. I'll take off the lens cover. This is actually a zoom lens. It's a telephoto lens. It's not a fixed focus lens like the others. You can see it's bigger than the others. And even though it's not the same as a big, Nikon camera or something like that, it is a zoom lens that can zoom in and zoom out. And this particular lens, this one is probably worth about $35 or $40. These components are really not that expensive. This particular lens has both infrared and normal sensors at the bottom of the camera. And it's not the same as cameras in the old days where we had all the apertures opening and closing and everything, except for the zooming in and out. It's pretty much electronic. There's almost no moving parts on these things. I mean, this is the one exception. You can see the others have no moving parts. So they're easy to manage, they're easy to handle, and you could use them for things like wildlife in the backyard. People have made baby monitors. You can build your own baby monitor. And you can have a unit like this with the camera in the baby's room, something in this footprint with the computer components inside. It can have sound sensors as well, and on your own personal computer at home, on your cell phone, whatever, you can pick up the signal that comes from this and keep track of the baby.
So when I opened the show, I mentioned something about one of the reasons for this movement had to do with STEM, younger children, and getting them a little bit more interested in technology. Exactly what impact, if any, is all of this having on the educational systems, either in our country or other countries around the world?
Well, there's a couple things going on here. First of all, you don't need to wait until somebody's a college student to start teaching them about computers and electronics, even the stuff inside the computers. There's an approach to education started by Jerome Bruner in the 1950s. Jerome Bruner was a psychologist up at Harvard. And after the Russians launched Sputnik, there was this big fear about, are we keeping up with technology and all that. So Bruner was head of a national committee that came up with this approach called the spiral approach to learning. And the idea is you start with children, perhaps even in kindergarten, and you teach them a little bit at a time about math, science, technology, engineering. And you layer that stuff on year after year. It's affected the curriculum in many places. In New York State, for example, we don't teach geometry in just 10th grade anymore. They learn it a little bit at a time over many years. And that's what we can do with this technology. We can have younger children start to play with computer components like this. This kit that I have here, this is called a CANA kit. And the CANA kit is a kit that you can use to build your own personal computer. And it comes with a set of directions that are geared toward 4th grade students. This is a project that a 4th grade student could acquire to build their own computer at home using the Raspberry Pi equipment that we have here. It doesn't include a monitor and a keyboard. That stuff is separate, but you build the basic computer. And as I said, it's at the 4th grade level. Robotics is very popular with kids. They start to learn about electronics, about mechanics, about physics, and so on, and about computer programming, of course, when they start to play around with a lot of robotics kits. I have a device here that I can show you. This is a robotic car. This is another kit. This comes from a company called Dexter Industries. Both Dexter and CANA are nonprofit, and they both started up with crowdsourcing. They asked for funding from the public to help build this company to make products to help teach children about technology.
So if I'm looking at this whole car, the way you have it set up here, it looks like this board is the guts or the actual thought process for the car, and that's plugging in right here. Is that what it's doing?
That's right. We actually have 2 circuit boards. I don't know how well you can see this, but there's a red board and a green board. The red board has the controls for the motors for the wheels and some sensors to tell how fast the wheels are going and a few things like that. That's the part that you buy from the company. And as I said, this was a kit with the wheels, the motors, the red board, all together, the battery pack. And then plugged in is a Raspberry Pi. It's actually the same as this. It's a Raspberry Pi Model 2 in this orientation plugged into the board. And the general purpose I/O pins in the Raspberry Pi plug into a connector on the red board, and you use the Raspberry Pi as the brain to control your computer.
Well, I think it would be really fun for us in the audience to actually see this in action. Would you like to show us how it runs around and how you control it?
Sure.
I mean, I don't see any controls. How do you do that?
Yeah, I'd be glad to show you that. What we have on this particular model, I have 2 USB devices plugged in here. Devices like this one, except they're a little bit smaller. And the 2 that I have plugged in there, one is for Wi-Fi. You can actually connect to the internet. And the other one is a Bluetooth receiver and transmitter. And I have a Bluetooth keyboard. Now, when you get a device like this, it comes with the software to make it work. You don't have to write the software yourself. But the software is free and open source, as I mentioned before, so you can actually change the software and modify it if you want to. But you don't need to be a programmer in order to get started doing this stuff. So what I've loaded into here and what's active and ready to go is a general purpose program to just let you control the vehicle from the keyboard. The vehicle has the 2 wheels, and in front, instead of a wheel, it's got a ball bearing with a mounting bracket for that. That's a little more bit robust for things running around on the floor.
So a tricycle.
Yeah, it's a tricycle. And also you can see these posts sticking up. You can put other devices on top of this. You can put a plastic cover on top. You can do different things. You can put it inside a stuffed animal. You can mount the cameras on it. They've had things where the kid's got the camera on it and he's driving into his sister's bedroom taking her picture and all kinds of stuff like that. This box right here is actually full of components that I bought separately. There's wheels, there's motors, there's plastic boards and so on here, a whole bunch of screws and wires, and you can actually buy the parts and design and build your own kits and program them. That comes as a kit ready to go. This is just the raw materials so that you can design and build your own stuff.
Well, why don't we give everybody a quick demo. When we come back in a few, we'll show you exactly how this runs around on the floor.
Okay, so here's the Raspberry Pi mounted onto the robot car, the tricycle as you called it, and I'm going to plug it in to the monitor and the keyboard and initialize the robot. You don't need to do that all the time, but I'm doing it now to get things started and to show you that this is a regular computer Once I plug it in, we're going to use it like a regular computer. And then the Raspberry Pi computer will program the robot and tell it what we want it to do. I'm plugging in an HDMI monitor, and I'm plugging in the power supply. And once I plug in the power supply on the monitor, we will see the startup sequence, the boot sequence from the Raspberry Pi. That takes a moment.
And I also see icons of the Raspberry Pis up in the corner of the monitor. We've cleared the table here for Chuck to be able to have a little bit more room to run his robot around so that we can see exactly what it can do and where it can go. How long does the sequence take usually?
It depends on the software you have. 30 seconds, 45 seconds. Again, it's a regular computer, and it goes through what every computer goes through. In this particular case, it's initializing everything because I had it powered down completely and disconnected from batteries or anything. So it takes a little bit longer.
Now, in order to program it, in one of our future programs, we're going to take a look at some of the programming languages that are available to program these types of devices. And please keep your eye out for those programs when Chuck comes back and talks about those languages.
What we have on the monitor is a standard Windows interface. This happens to be called X Windows. It's free open source software. We're not using things like Microsoft Windows. And I'm going to go into the GoPi Go software that comes with the robot kit. And I'm just going to run a program to initialize the robot so it will accept commands from the keyboard. You can write code to make it do things automatically and remotely. In this case, we're just going to make it work from the keyboard. And for me, the easiest way to do this is for me to just type in the command to start the program. It's a standard Linux operating system, and I'm using the Python programming language. And I'm just typing in the program to run the Python program I need to make this work. Okay, so we're all set. And I'm going to disconnect the monitor. I've just run the program so that we can control this from the keyboard. I'll disconnect the monitor and disconnect the power supply so it's running on battery power. So it accepts different keyboard commands. Backwards. Turn, right into my keyboard. Come over and visit you, Arnold.
I see. Oh, and look, it does ballet moves too.
Anyway, there's not a lot of room on the table. I don't want to run it off the table, but you get the idea. There's a lot of different kinds of robots and vehicles you could build. There are ones that have tank treads and so on. They're not that expensive. The wheels are about $1 a piece. These motors are about $3 a piece. The controlling circuit board is about $7 or $8. It's not, as I said, not that expensive. The rest of the components are cheap, and you can design and build something yourself. And with this device and the cameras I showed you and most of the things people are doing with Raspberry Pis, the hardware comes with what's called an application programming interface, an API. An API is the software you need to make the device work, and it's set up so that it'll give you a set of simple commands to use the device. And because it's open source, you can just use the commands and program the device to do whatever you want it to do, take pictures, move around, whatever. Or you can go in and start to change the code. And that's where a lot of people, high school students, for example, are learning about programming, by learning to go in and start manipulating the code to make these devices work the way they want.
Well, I can see where I think younger people would be very interested in something like this, because my children, when we bought them radio-controlled cars, they could pop in the batteries and just run the car, but the fact that you could actually build the car from scratch and then start to control it, I think that's where the maker movement and the STEM areas are coming together, where maybe the younger children are going to get more excited about programming. So is this somewhere moving into the educational areas within our country or Great Britain?
A lot of places. In Great Britain, BBC, British Broadcasting, has always been a proponent of computer literacy, computer education, and they now have a device called the Microbit, which looks very similar to the Raspberry Pi. It's made by the same people. The Raspberry Pi started in Britain. The BBC was a big supporter of it when it started. And the Microbit is given to every 11-year-old in Britain. At the beginning of the school year, they get the Microbit device, and the teachers are given kits to use the Microbit in different experiments in different classrooms throughout the year. They can use it in math class. They can connect it to a printer and plot things. They can use it in a chemistry class. They can connect it to sensors and so on. There's an awful lot you can do with it. And you can see how I showed you the cameras. Remote sensors are the same thing. You can measure the temperature of something, pressure, and so on. You can embed these things inside a ball and play a game and have the ball track. If you've ever seen the IBM things at Wimbledon where the tennis ball is on the line or off the line, well, you can do that kind of stuff with a ball you build yourself. It's a little bit more robust than this robot, but it's the same idea. So there's a lot of different things that are happening with this in the educational marketplace. And in the United States, the National Science Foundation is supporting STEM grants around the country to introduce this technology at all levels of education. In graduate school, they're experimenting with remote sensing devices. In high schools and colleges, they're experimenting with writing the software. And in elementary schools, to introduce students not only to computers and electronics, but to things like physics, moment of inertia, momentum, all kinds of things you can do with it. And of course, the basis for all of this technology is the M part of STEM, S-T-E-M, the mathematics. And that's really the important thing as far as younger children are concerned. We're getting them to play with math, to figure out angles and distances and to equations in a way that's fun and interesting.
Well, I can certainly see where I think a lot of children would be excited to work with this device, program it, and also the current TV station, or the current TV show is BattleBots, where people are programming robots in an arena to see who can make a better robot to do different things, and this certainly is the beginnings of such a thing.
Raspberry Pi Foundation has an annual contest for Raspberry Pi robots, several different contests. They have races, obstacle courses, and the BattleBot kind of thing.
Well, I think we've pretty much covered a lot of different avenues of exploration, a lot of different information about the Raspberry Pi, its history, some of the other devices that are similar to it. And we would like to wrap up today's show, but remind you that we're going to have Chuck back as a guest for a couple other shows. The next show we'd like to show how exactly to build it, how to put it together and create your own personal computer that would be able to run all kinds of software similar to Microsoft Word and Excel. And I believe Chuck will be able to even do a PowerPoint type presentation directly from his little Raspberry Pi onto our monitor. And then in a subsequent show, we would also like to be able to show you how to actually use the programming languages similar to what he has shown you today, Python, Scratch, and there may be others.
By the way, Arnold, the website, raspberrypi.org, is a good place to go to for more information about the Raspberry Pi. All of this stuff can be purchased a lot of places. The Radio Shacks that are still open sell Raspberry Pi kits from the Make company and Make Magazine. MakeMagazine.com is a good place to go. Amazon has all this stuff available. This is a Raspberry Pi user's guide. This book costs about $11. It's published by the people who make the Raspberry Pi, and it's got everything you need to know to get started using the Raspberry Pi.
And again, as we can see, it's Raspberry Pi, P-I, so if you're going to the website, it's raspberrypi.org. That's all the time we have for today. I'd like to thank my guest, Chuck Herbert, for joining me today, and I'd like to thank you for tuning in. You've been watching Tech for You on CCP TV, the educational channel of Community College of Philadelphia. I'm Arnold DeBlasi. See you next time.